All right, pre-calculus. This video is still in Unit 7, and we are still looking at Topic 4, which is just using the sum and difference identities. So over to the right here, I have put my identities here and my unit circle just to make this easier to follow. So example 2, find the exact value for cosine 5 pi over 12. Okay, this will be so much easier if you just convert anything you have in radians to degrees. So that's the first thing we're going to do. So if you'll remember from a couple of units ago, all I have to do is multiply this by 180 over pi. And it gives me 75 degrees. I cancel that. Multiply 5 by 180, divide by 12. So I end up with 75 degrees. So again, 75 degrees, just like on the example 1 for cosine 15 degrees, 75 degrees does not occur on the unit circle. So something obvious probably is that we could look at using 45 and 30 and just adding those together. Now, kids, if the combination of numbers I'm using as a sum or difference to get what I'm looking for here, in this case 75, if that's not the two values that speak to you, you can use any combination of numbers that add or subtract to give you 75. It does not matter. You will still get the same answer. So if I've got this changed now to 75 degrees, so I am looking for the cosine of 75 degrees. And 45 and 30 will add nicely to give me, that's right, 75 degrees. So this means that I am going to change cosine 75 to cosine 45 degrees plus 30 degrees. And so I'm going to visit my sum and difference identities here. That is cosine A plus B because I'm adding two values. So that means I can look at this as cosine 45 and 30. So A is going to be 45, B is going to be 30. So I am going to rewrite this as cosine A, so cosine of 45 degrees times cosine of 30 minus sine of A, which is 45, times sine of B, which is 30. Okay, visit your unit circle. Cosine of 45, radical 2 over 2. Cosine of 30, radical 3 over 2. Sine of 45, radical 2 over 2, sine of 30, 1/2. Yay. Multiply, I get radical 6 over 4 minus radical 2 over 4 equals radical 6 minus radical 2 over 4. Neato. All right, now we're going to look at example 3. So for this one, it's sine of 165. So let me erase my unit circle here and my markings. So the exact value of sine 165. Well, again, 165 doesn't occur on the unit circle. It would be somewhere in here. So that means I need two values that either add or subtract to give me 165 that do occur on the unit circle. So the most obvious one to me, I've got 135 here and 30. If I add those together, I get 165. So I will use sine of 135 plus 30. I'll use that. So that means sine of two things added together, so a sum of sine. So I am going to look at this one right here, sine of a sum. That's why they're called sum and difference formulas or identities. So A is 135 and B is 30. Does it matter which one I put first? No, because they're being added together, so that does not matter. So what I have here is sine of A, so sine of 135 times cosine of B, so that's cosine of 30, plus cosine A, so cosine of 135, sine B, so sine of 30 degrees. Now I'm going to replace those with their values on the unit circle. So the sine at 135 is this one. The cosine at 30 is this one. The cosine at 135 is negative radical 2 over 2. And the sine of 30 is 1/2. Radical 2 times radical 3, radical 6 over 2 times 2, which is 4. This becomes a negative now. Radical 2 over 4. Wow, Miss Griggs, that's the third time now on these examples we've gotten a combination of radical 6 and radical 2 over 4. It's almost like that always happens. Yes, it always happens, babies. Okay? All the time. You always should have some combination of radical 6 and radical 2 over 4. Sometimes they'll both be positive, sometimes they'll both be negative, sometimes one will be positive, one will be negative. Okay, but yeah, it always works that way. Okay, let's look at example 4. We now want to find the exact value of sine 120 minus 45. So for this one, I've told you what you're doing. You don't have to figure out which one it is. So the sine of 120 minus 45, that's going to be the difference here. So that means A is 120 and B is 45. So 120, 45, 120, 45. So the sine of 120 degrees minus 45 degrees can be written as sine of A, so sine of 120, times the cosine of B, which is 45, minus the cosine of 120 times the sine of 45. Now we're going to use the unit circle to replace these. So sine of 120 is radical 3 over 2. Cosine of 45 is radical 2 over 2. Cosine of 120 is negative 1/2. And sine of 45 is radical 2 over 2. Groovy. Radical 3 times radical 2, radical 6, that's a big surprise. 2 times 2 is 4. Notice what happens here. This changes to a positive. Oh my gosh, we got another combination of radical 6 and radical 2 over 4. It always works that way, kids. All the time. Trust me. Okay, now let's look at example 5. It's a little bit different. This one is asking us to write a single term expression for this right here. So basically what you're doing is you're using these up here and you're writing backwards. That is what is happening. So let me just move this down here so we can see it easily. Okay, so I want you to notice something. We have sine of a value, so let's call this A. And we have cosine of a value, let's call this B. And then we have plus cosine of A, sine of B. Okay, because 140 is A and 50 is B. So I'm going to look for the one on this side that looks that way. Okay, so sine, okay, both of those look that way. Cosine, okay, but this is plus. And then cosine A, sine B. So it's this one, all right? It's this one. It's what we're interested in. So we're working backwards. So I have sine of 140. I've got this side over here, and I want to write it this way. So A is 140, so I write sine, see this right here, of 140, plus B, which is 50. So then I just write it as the sine of 190. See, single term expression. Done and done.